So we've already talked about different forms of an equation, and for this lesson, which is Unit 5, Lesson 2, and Lesson 3 on writing equations from graphs, we need to be able to look at the three different forms of an equation and be able to write an equation in those three forms. So slope-intercept form is probably the most common. We've used this one a lot. Y equals mx plus b, where m is the slope and b is the y-intercept, so where it's crossing our y-axis. And an example of an equation in that form, y is by itself equaling 2x minus 6, where 2 is the slope and it's crossing a negative 6 on our y-axis. The second type of equation that we've looked at is point-slope form. And that uses this equation, y minus y1 equals m times x minus x1. And m is still our slope, and this x1, y1 refers to a point on the line. So our x-coordinate and our y-coordinate, we're going to plug in for our y1 and x1. In an example equation, y minus 3 equals 4 times x plus 6. And the last form of an equation is standard form, and we've talked about this one briefly, just not very much. So standard form is written as ax plus by equals c, where a, b, and c are all integer values, meaning they can't be fractions or decimals. So an example equation in standard form is 5x plus 3y equals 20. And a special note here, the x and the y terms are on the same side, equaling a number. So standard form equations are going to look like this. Now, to write an equation in standard form, start off with point-slope form, and then translate to slope-intercept form, and then translate to standard form. Sometimes if you can easily see from slope-intercept form what that equation is, specifically where it's crossing our y-axis, you can skip point-slope form. But this one, notice how where it's crossing my y-axis is between unit 0 and 1. I don't know exactly what that is, so the only way to find out exactly what the equation is to start off in point-slope form. So all of these are going to need slope, so start off finding your slope. So slope is equal to y2 minus y1 over x2 minus x1. And my y-coordinates, I have a 7 and a 2. So 7 minus 2. And x-coordinates are a 9 and a 2. So 9 minus 2. 7 minus 2 is 5. 9 minus 2 is 7. So the slope that we're going to use is 5/7. Now, for point-slope form, you can choose either point. It doesn't matter which one. But you're going to write it in point-slope form. So y minus y1 equals m times x minus x1. So choosing one of them, I'm just going to choose this point here, 2, 2. So y minus my y-coordinate of 2 equals my slope, we calculate out to be 5/7, times my x-coordinate, or x minus my x-coordinate was 2. So this one here is point-slope form. So here is the equation in point-slope form. To write it in standard form, you need to multiply through the slope and work to get your y by itself. So I'm going to change my color so while I switch to the different type of equation. So y minus 2 equals 5/7 times x minus 2. Your first step, use your distributive property to multiply that slope through to both terms. So y minus 2 equals 5/7 x minus, and then 5 times a minus 2 is a minus 10. 7 times 1 is 7. So we've distributed through our slope. Next step is to get y by itself. So we would add 2 on each side. So then we have y equals 5/7 x. And now this other thing, notice this is a fraction. I can't just add 10 plus 2 to get 12. That's not how we add fractions. To add fractions, we have to make sure they have a common denominator. So a negative 10/7 plus 2, think of it as 2 over 1. You need to rewrite this so it has a denominator of 7. To do that, you'd have to multiply the top and the bottom by 7 to find an equivalent fraction. So really, this becomes negative 10/7 plus 14/7. Negative 10 plus 14 is a positive 4. So we actually have a positive 4/7 because negative 10 plus 14 is a positive 4. Denominator stays the same. This is our equation in slope-intercept form. So we've got our equation in slope-intercept form. To go now into standard form, I'm going to change my color one more time to a green. So now to go into standard form, I want my x and my y terms on the same side and no fractions. So y, starting from slope-intercept form, so here is our equation in slope-intercept form. To get my x and my y on the same side, this 5/7 x is positive, so I would subtract x on this side, subtract it off. So subtracting a 5/7 x here and subtracting a 5/7 x here, these two cancel off, and you're left with a negative 5/7 x equaling, plus y. So hang on here. So plus y, that y is still there, so plus y equaling 4/7. So we're almost there. I've got my x and my y terms on the same side, but I've got fractions. I've got two fractions with a denominator of 7. Since the denominator is the same, to clear out a denominator, think of this is like dividing by 7. So negative 5 divided by 7. 4 divided by 7. The opposite of dividing by 7 is to multiply by 7. And you're going to multiply each term by 7. In this particular lesson, they don't want this x term to be negative, but I'll just do that last. So I'm going to multiply every single term by 7. So 7 times a negative 5/7 x plus 7 times y equals 7 times 4/7. These 7's now cancel out. 7 cancels out with 7. And you're left with a negative 5x. And then this one, 7 times y is 7y. And then 7 times 4/7, this 7 cancels off with this 7, so it equals 4. Now, you could stop here. This is in standard form, but in this course, in this book, they don't want your x term to be negative. So to change it so that it's not negative, it's like multiplying through by a negative 1 or dividing each term by a negative 1 or changing the sign of every term is essentially what's happening. So if you divide everything by a negative 1, negative 5 divided by negative 1 is a positive 5x. 7 divided by negative 1 would be a minus 7y. And 4 divided by negative 1 is a minus 4. So this is our equation in standard form. So here is standard form. What's important again for standard form, have your x and your y terms on the same side, no fractions or decimals, and if your x coefficient is negative, just divide everything by negative 1, and it changes the sign of everything so that your first term is positive. And then one last thing for equations of horizontal and vertical lines. All vertical lines, notice, are going through our x-axis. So this line here, I can see has an x-coordinate of 3, an x-coordinate of 3. Anywhere on here, it's going to have an x of 3. The x-coordinate is 3. So the equation of this line would just be x equals 3. Our other ones, our horizontal lines now, notice our y-coordinates are the same. Negative 5, negative 5. Anywhere on this line, my y is going to be a negative 5. So the equation of this line would be y equals a negative 5.